What does this mean? It means differentiate with respect to x. So this is a question we've done before. If we wanted to do the derivative of this, we have to do the derivative right here. What's the outer function here? What's the outside function? Cosine. And then on the inside, we have two things multiplied together. So if we do this, what's the derivative of cosine? So we have negative sine of xy. And now what do we multiply by? The derivative of xy. But what do we have to use to do the derivative of xy? Yeah, so the derivative of the first, which is 1 times y, plus x what? Y prime. Plus, what do I drop to the front on this one? What do I drop to the front? 2. So it's 2 times sine of x, and then what do I multiply by? The derivative of sine. What's the derivative of sine? Cosine x, and it equals what? 0. So now if I wanted to answer this question, find dy dx, what do I need to isolate? The y prime. That's another way of writing y prime. Exactly. So now we've gone from doing calculus. Now what are we doing? Algebra. Calculus to doing algebra. So now it's just algebra. You have to take it exactly what they sound like. Related rates are exactly what they sound like. We are going to be relating rates together. In this case, the rocket ship is going up, and the distance between the camera and the rocket is increasing. A rocket is launched, and you are a certain distance away, and the camera is tracking the rocket. You can relate many rates together. So, for example, how fast a car is going to gas consumption, how much water is going into a tank, to how fast the height of the tank is rising. So you can relate two rates together. If you are going to relate two rates together, you have to have an equation that relates those two things. So in this case, what's one thing that's changing in this case? What's one thing that's in motion? The rocket ship. The rocket is in motion. So you're going to relate the rocket speed to the distance between the camera and the rocket. When you're doing related rate questions, it's just like word problems, because they are word problems. What's the first thing you do when you're doing a word problem? What's the first thing you do? Yeah.
Figure out which information is useful and what's
useless. And before we even do that, in order to figure out what's useful, you need to what? You need to be able to imagine what's going on. You need to understand what's going on. And you can do that in a bunch of ways. In this case, let's draw a picture. So what's going on? There's a rocket. There's a rocket, and what's it doing? It's going up. We're assuming the rocket's going straight up, by the way. So here's our rocket. Oh, nice. And we have a camera that's a certain distance away. Oh, here's the camera. And the rocket's going up, and we could label some distances here, right? How far is the camera from the base of the rocket? So it launched from right here. So it says that this distance is 3,000 feet. And what distance are we trying to measure, or the rate of change? Or what distance? What do I have to connect if I needed to complete this picture? What should I connect?
The height of the rocket.
To
How far away it is. Yeah.
The distance to the camera. So this right here is the distance we're tracking. So as the rocket goes up, this distance increases or decreases? As the rocket goes up, it increases, right? It increases. It increases. It increases. Down, as I like to break it down into what do we know and what do we want? What do we know and what do we want? In terms of what we know the height, how fast the height of the rocket is changing. How fast is the height of the rocket changing? What do we know? 880 feet per second. We need to be very careful with our labeling. So let's call the height of the rocket h. Are we okay with that? In terms of derivative notation, how do you write the rate of change of the rocket with respect to time? D what over d what? Yeah, we know that dh dt is what? 880. The height of the rocket is changing at 880 feet per second. What do we want? Well, we have to label that blue distance. What do we want to label that blue distance? What letter do we want to give it? Anybody want to label it for us? Pick a letter.
B.
B? Sure. That distance is B. That distance is B. So what rate do we want? What rate do we want? What rate do we want?
B.
B is not a rate. B is the distance. Yeah?
Like B when B increases.
No. In terms of derivative, d what over d what?
dB over dH.
Yeah. Nope.
No, DH over dB.
Nope. dB dt. This is really tricky at the beginning because we know how fast is the rocket going? That's the rate of change of the height in terms of time is 880. We want to know dB dt. That's what we want to know. So the first thing you identify is what do you know and what do you want in terms of the rates of change. We know this rate of change and we want this rate of change. But if we want dH dt, if we know dH dt and we want dB dt, we need an equation that relates what to what? We need an equation that relates what to what?
The b to the h.
Yes, we need something that relates h and b. We want a relationship between h and b. What relationship do we want? Between h and b. Because if we get the relationship between h and b, we can take the derivative of that. What shape do you see on the board right there? And I'll write that legibly. What shape do you see right there? So if we use the Pythagorean theorem here, we need to label one more side of that triangle. What's the other side of that triangle? What letter do you want to call it? What letter do you want to call it?
G.
What?
G.
G? So can you relate to me B, H, and G for me, please? G squared plus...
G squared equals B squared.
Nice. All three of those we can write in terms of t. We don't know what they are, but we're going to differentiate this with respect to t. Why do we know we're differentiating with respect to t? Because that's the derivative we want. We want it in terms of t. We're going to do implicit differentiation in terms of t. So could somebody tell me what that implicit differentiation is in terms of t? Anybody? You can. It's much more straightforward than you might think it is. What do you drop to the front? No. Don't plug anything in. Don't look at anything here. Just tell me what's the derivative of that in terms of t? What do you drop to the front?
The 2.
Yeah. So it's going to be 2g times dg dt plus what? Plus what? 2h dh dt equals 2b dB dt. And you're like, oh my god, that's a lot of derivatives. Oh my god, what do I do? Well, first, can we cancel something?
Yeah.
What can we cancel, Liv?
The 2.
We can cancel the 2's. Nice. Do we know one of these rates of change?
Yeah.
Which rate of change do we know?
The 3 or the G.
dH dt. We know dH dt, right? So what do we now know? We know g times dg dt plus h times what? 880 equals b times what? dB dt. Which is the one we want in there? Remember, what do we want? What do we want? dB dt. So we need to get values for everything else. It looks like we don't have them. We actually do. Can someone tell me what dg dt is? Where's g? G is the base, right? Can someone tell me what dg dt is? You know what it is. No. 3,000. G is 3,000. What's dg dt?
0.
Why is it 0, Annie?
Because g is a constant outside of it and it's 0.
Well, what's a constant? G is not a why is G a constant?
Because it's a number.
Yes, but why is it a number? Use the word camera in the sentence. Because the what? Because the camera isn't
Moving.
because the camera isn't moving, dg dt is what? 0. What is G?
3,000.
3,000. So what can you plug in? 3,000 times 0. Oh, we plug in that. 880 equals b times dB dt. Hey, we plugged in one more thing. Oh, but what's this right here? 0. So now we need h. Oh, wait. What's the rest of the question say? When the rocket is 4,000 feet in the air. So where do we plug in 4,000? So h is 4,000. So we have 4,000 times 880 equals b times what? So what's the only thing we need now to get this question right?
B.
We need to get b. Yes, I understand, but knowing the answer doesn't tell me how you got it, Sarah. So don't apologize. I'm just explaining more. You need a little to give me more. We know that that's 3,000. This is 3,000 right there. We know the height is 4,000. So we know that 3,000 plus 4,000 equals something squared. What goes right there? Sarah, do you want to finish it for us?
25 million. Oh, no, 5,000.
5,000.
Sorry, yeah.
When this is 3,000 and when this is 4,000, because we know the Pythagorean theorem, what does this have to be?
5,000.
5,000. So we plug in 5,000 for what?
B.
B. plug in 5,000 for B. So what does this tell us? When H is 4,000, B is 5,000. So what do we have here? We know that dB dt is equal to 4,000 times 880 all over what? 5,000. Can someone pop out their calculator and tell me what that is? Did you say 704?
Yep.
And what's the units on that? I think it's feet per second. Is it feet per second?
Yep.
Feet per second. In physics, I know you have to put units on all the time. I'm okay with it just being at the end. The radius is what? The rate of change of the radius. So how do you say the rate of change of the radius? D what over D what? Yeah, you know dr over dt. You know dr over dt. And what is dr over dt? 2 feet per second. There's what you know from there. What do you want? So d what over d what? Yeah, sure. dA over dt. We want that. We want the area right here. How fast is the area changing? So we know there's what we know for a rate and there's what we want. So we need to relate radius and area of a circle. Do you have an equation that relates radius and area of a circle?
Yeah.
So we're linking. So now we want to link R and A. Calling that one A. Can someone tell me what that equation is? Sarah.
A equals pi r squared.
A equals pi times R squared. So we have what we know, we have what we want, we have the link, and now we have the equation. Oh, that's nice. So now what did we do next after we had the equation? We're pretty much home free now. We're pretty much home free. What do you do now with that equation? Find the derivative in terms of t. Can someone tell me what the derivative in terms of t is? This one is simpler than the other one. Sometimes it seems harder, but this one is simpler than the other one. What's the left side become? What's the derivative of a in terms of t?
A.
dA dt. And what's the right side become? What do you drop to the front? 2 pi r times what? dr dt. Yeah, like that. Is equal to 2 pi r times what? Times 2. Now there's one thing left we have to find a value for. It's that r value, right? Oh, is that already there?
Yeah.
Of the spill is 60 feet, right? So where does that go? Oh, we put 60 in there, and what do we get? dA over dt is equal to 2 pi times 60 times 2. So what is that? 240 pi? What's the units on this? Be really careful. What's the units?